All right, here's a circuit. We have a series parallel network, once again, where you have part of this in series, part in parallel, and we're trying to find the equivalent resistance of the circuit. So we've got a couple ways to approach this. One, hopefully when you do a little bit of practice, you'll be able to identify what parts are in series, what are in parallel. What I'd like to do again is to draw the pathways that the charge can pass through. Well, if I start from positive, I definitely have to go through R1, then I get to a split, and I can go through R2, and then I merge back together and I go through R4. There's one possible pathway back to the source, or I can take the same path but continue straight at the split and go through R3. So we have two loops. Anytime you have more than one loop, then you definitely have part of that circuit in parallel. And so each loop, you're going to pass through 3 resistors and drop that 10 volts. So let's look at how we can actually find the equivalent resistance. One way is to identify that right here you have 2 resistors that are parallel. Those are the 2 pathways where you have the choice. Right? And if that's the case, we can find the equivalent resistance by taking 1 over 30 plus 1 over 50 and finding the equivalent resistance of that branch. Another way to write that in your calculator would be 30 to the negative 1 plus 50 to the negative 1 and raise that whole thing to the negative 1. So in my calculator, that's how I would evaluate it. Now, doing some mental math, it should be less than 30. If it was 30 and 30, it would be 15, but it's 30 and 50. So I'm going to guess somewhere between 15 and 30, maybe around 20 would be my guess if I'm estimating. So let's see what we get. Hey, I get 18.75. So my equivalent resistance of that branch is 18.75. And so if I was going to redraw this circuit, I could actually redraw it now as a 20, an equivalent of 18.75, and then you definitely have to go through the 20 again. Do you guys see how we do this? So I've replaced the 30 and the 50 with one equivalent resistance. And now I clearly have one pathway through all 3, and I can add up all of those. So REQ would now be 20 plus 18.75 plus another 20. And so I get 58.75 ohms as the equivalent resistance. All right, so again, this is one method, is to look kind of far away from the power supply and redraw where I see this parallel. Other way I looked at it was to redraw the circuit altogether by starting at the positive end and starting to move through the circuit. So I would move through, I definitely get through R1, and then I get to a split. So I'm going to go through R1, and I'm going to hit my split. There's 20. And at that split, I split 2 ways. I can take a high road and go through the 50 back to another node. Or I can take the low road and go through the 30. And they both meet that back up. We'll call this A and B. There's B. And then I continue on through the 20 and back to the source. All right, so when I do this redraw, you can clearly see the series and parallel components. So I can say, well, 20 plus the parallel combo, 30 to the negative 1 and 50 to the negative 1, all the negative 1, plus another 20. That would be my equation for REQ. And like I said, this part of that is equal to 18.75. And when I add it all up, I get my answer of 58.75 ohms. So kind of 2 methods to look at how to break this thing down. The more you practice, you might do a combination of these methods when you start looking at complicated circuits. What I think some confusion comes from is that term parallel. Guys start looking for parallel lines. This circuit can be drawn a lot of different ways. The fact that the 20 and the 20 are visibly parallel lines does not mean they are parallel circuit pathways. Parallel pathways is more to do with whether there is a split or not. And so it's helpful to kind of draw those loops in your circuit to identify what parts you have to pass through, and therefore they're a series, or which parts you have a choice, When you have a choice, you have a parallel pathway.